Alrighty, today's video is going to be going over empirical formulas. So what is an empirical formula? My slide will change. An empirical formula is a formula that shows the smallest possible whole number to describe atomic ratios. Okay, this is the simplified version of a formula. Okay. So the steps when we're finding empirical formulas, we first need to find that percent composition of each element. So the previous video went over percent composition, so make sure you have a good understanding of that before you try to start tackling empirical formulas. So after you find that percent composition, you're going to convert that percent to grams. We're then going to go from grams to moles and then divide by the smallest amount of moles. So go ahead and write those steps down and keep those in your head as I show you a little practice problem doing this type of work. So our example that we're going to go over is what is the empirical formula of a compound whose mass percent is 78.1% B or boron and 21.9% hydrogen. So let's go over this one together. Alrighty, so I have my little percents written out here. And remember, my first step was to find the percent composition of each of our compounds. However, in this problem, it's already done for you, and sometimes that's going to be the case. So we already know our percent composition of boron and hydrogen. So step one is done. Our next step is to convert this mass into grams, okay? And this is actually going to be a pretty easy step, okay? It might seem a little tricky to you, but we can easily turn this percent into grams. If we assume, you're always going to assume we have 100 grams of substance, okay? So unless you're told differently, always assume we have 100 grams of a substance. So if we have 100 grams of whatever this compound containing boron and hydrogen is, what's 78.1% of 100? Pretty easy. It's just 78.1 grams of boron. Same with hydrogen. 21.9% of 100 is 21.9 grams of hydrogen. Okay, so step two is also pretty easy. From there, we're going to be converting to moles, so you're going to have to think back to the beginning of the unit when we learned how to do that. And we know to go from grams to moles, we need to use our molar mass. Our molar mass of boron, if we look at our periodic table, is 10.81 grams of boron, and that's going to be equivalent to 1 mole of boron. Okay, we have grams on top, we have grams on bottom, so we can cancel out our unit of grams. Okay, and then it just becomes an easy division problem. So when I divide this, I get 7.22. So just hold on to that number for a little bit. And let's go down to our hydrogen and turn that into moles as well. Okay, we're going to do this the same way. Our grams of hydrogen are going to go on the bottom, and to find that number, I am going to look at the periodic table. My atomic weight of hydrogen is 1.01 grams, and that's equivalent to 1 mole hydrogen. Cancel out my grams unit. Do some simple dividing. 29.9 divided by 1.01 will give me 21.7. Okay. This next step is the new thing we're going to learn in this unit of dividing by the smallest number of moles. So you need to compare these two values, 7.22 and 21.7, and decide which one is smaller. Clearly it's this one. So you're going to divide both of your numbers by 7.22. Okay, 7.22 divided by 7.22 is 1. 21.7 divided by 7.22 is going to turn out to be 3. These values are important. These values tell us that we have 1 copy of boron and 3 copies of hydrogen. So our formula here would be boron 1, hydrogen 3. And that's going to be our empirical formula. This process will work almost perfectly every time. However, sometimes you might get a wonky number. So let's just pretend here that instead of when we got 1 and 3, we get 1 and 2.5. Okay, does it make sense to have B1H2.5? No, of course not. We've never done a problem like that. So what we need to do is make this its nearest whole number. Okay, so 2.5, if we multiply that by 2, we get the number 5. Okay, so we'd have B1H5. However, if we've multiplied this by 2, we also need to multiply this by 2. So our answer here would be B2H5, okay? And of course, that's not the answer to this problem, but that's what you would do if you come across a problem that has not a whole number, okay? Sometimes you might get 1.98 or even 1.9. Those are okay to round up to 2 without having to multiply, but if you have something anywhere between like a 1.2 to like a 1.8 or like 2.2 or 2.8, those are numbers you are going to have to multiply out to get the correct answer. Okay? Let me know if you have any questions on this. Otherwise, have fun with your homework.